It's time for another app. And in this course section, we're going to build this meals app, which allows users to browse various meal categories, pick meals, and read the meal ingredients and instructions, mark meals as favorites, switch between all meals and favorited meals, and also switch to a totally different page where various filters can be set to filter the meals that will actually be shown in this all meals area here. That's the app we're building, and the special thing about this app is that it has multiple screens between which we, the user, can navigate. We can go forth and back and use the tabs to go to different areas of the app. We can use the side drawer to switch to a different screen. And that is, of course, something we haven't done at all in this course up to this point. But this navigation between different screens is, of course, something you will need in a lot of apps you might be building. And therefore, this course section here is about navigation in Flutter apps and how you can build multi-screen apps that do allow users to navigate between those screens. And for that, we're going to learn about the concept of screen stacks and how we can dive deeper into an app by adding screens to that stack or going back by popping screens off the stack. You will learn how to add a tab bar and how to make sure that users can use that tab bar to switch between different screens. And you will also learn how to implement a side drawer and how to use that to switch between different app areas. And as always, along the way, you will also have plenty of opportunities to practice what you already learned up to this point, to work with more widgets, and to also learn about some new concepts and widgets. Now for this section here, I got another new starting project created with Flutter Create. I named it Meals. And in this project, I got a main.dart file, which you also find attached to this lecture here. Now this main.dart file has a couple of issues right now. We're going to fix them in a couple of seconds, but you should use that attached main.dart file and replace yours with it. And once you replaced your file with it, you should install the Google Fonts package, since I'm using the Google Fonts to actually override the default text theme with one of the themes defined by that package that uses a different font family, the Lato font family in this case. This is something we haven't done up to this point in this course, but it's a very convenient and easy way of overriding the default text theme with another text theme that does use this specific font. And the Google Fonts package offers pre-built text themes for all the fonts it provides. Therefore, you should install this Google Fonts package for Flutter by following the official installation instructions, which simply means that you should run this command here. And once you did that, the first error will have been fixed. Google Fonts can be found now. And the only remaining error now is that you must set some widget as the main entry widget of your app. So we need a main entry widget for our app. And for this app, I'd like to get started with this categories screen, where we can then select a category and see all the meals that belong to that category. And therefore, I'll add a new file here in this project's lib folder, which I'll name categories.dart, because in there, I want to build the widget that displays all these categories. Now, inside of categories.dart, you should therefore create a new class, the categories screen class, for example. The name is up to you, and you could also just name it categories, but since this will act as a screen in this app, and we will later have multiple screens, but also some regular widgets which don't act as screens, I want to mark the widgets that will act as screens. So therefore this one is the categories screen, and we of course extend stateless or stateful widget here, and here we'll only need a stateless widget because indeed there won't be any internal state that would need to be managed in that widget. Sure, we'll be able to select a category later, but as you will see, the navigation to the screen that shows all the meals for the category will not be handled with state, but instead with a different mechanism. And therefore this indeed can and should be a stateless widget. Now, of course, as always, we need the build method, and we should add a constructor function here. Categories screen is a fitting name, where we should accept and forward the key property as always. And here in the build method, I want to return the scaffold widget because I want to have that default styling that it applies. I want to be able to add the app bar at the top and so on. And in general, it's very likely in Flutter that if you're building a multi-screen app, that every screen will use the scaffold widget to do its base screen setup, because, for example, the app bar often differs between different screens. Different screens might have different titles or buttons in the app bar, and therefore being able to set the app bar or other screen-specific settings right from inside the screen widget is a common requirement, and hence it is quite common to set up the scaffold widget inside of the screen widget, as we're doing it here. So here I will indeed add the app bar parameter and set this to app bar. So I'm using the built-in app bar widget again, as we did it before in the course. And on that app bar, I'll set the title parameter to the text widget and output some text as a title in this app bar. And the text here could be pick your category or anything like that. Now we can also add const here since this is a constant widget, but of course that's not all I want to do in this scaffold here. Instead, we also want to set the body. And the body, as you learned before, is the main page content. Now here for the body, I want to output all these different categories, which then later can be selected to move to one of those categories. And for this app here, I plan to lay out these categories as a grid. And thankfully, creating such a grid is also quite straightforward in Flutter because it does not just offer a list view for rendering a list, but also a grid view for, you guessed it, rendering a grid of items. And here, just as with the list view, you also have a builder constructor function, which would allow you to build the grid dynamically if you had a potentially very long list of grid items. But alternatively, you can also instantiate the grid view widget like this to not get this possible performance optimization of only rendering what's visible. But here I won't have that many categories, so that performance optimization wouldn't really kick in anyways. And therefore I'll use this approach where I can directly set my children, so the items that should be displayed in the grid. Now, grid view also needs something else. As you can see in this error, it needs a grid delegate, which should be set. And therefore, besides setting the children, which we will soon do, you also must add the grid delegate parameter here. And this is a parameter which might sound quite strange, but in the end, if you hover over it, you learn that this in the end simply controls the layout of the grid view items. And here I'll create a grid with this sliver grid delegate with fixed cross-axis count option, which is a very complex way of saying that I can in the end set the number of columns which I want to have here. So here I can set my cross-axis count to 2. And since by default the grid view main axis is from top to bottom, the cross-axis is from left to right. So if I set this to 2, I get 2 columns next to each other. So horizontally I have these 2 columns. Now with that set here, we can also set a child aspect ratio, which will impact the sizing of those grid view items. And here I'll set this to 3 divided by 2 to in the end dynamically derive a 3:2 ratio. Alternatively, you could also manually set this to 1.5. I'm just using this notation to make it clear that this in the end is the aspect ratio which I want to have. And I'll also set a cross-axis spacing of 20 to have some spacing between the columns. And a main axis spacing of 20 as well, so that I have a spacing of 20 pixels horizontally between my items and vertically between my grid items. And this can then also be turned into a const object. So that's the grid configuration. Now we can add our grid items here. And I'll add the actual data soon enough. For the moment, just to see whether it works, I'll just add a bunch of dummy text widgets. 1, 2, 3, 4, 5, and maybe 6. We can add const here to see whether this grid is displayed as intended. So with that all set up, we can use our categories screen in the main Dart file here as a value for home, where we can now use categories screen like this and actually add const in front of it. And of course, also make sure that you added the import to the categories Dart file. With that added and this set here, you can save this. And if you then run the app on an emulator, as we did it many times before in the course, you should see a screen that looks something like this. And of course, the text is not super readable here. So let me quickly fix this, even though this is just a temporary placeholder and will soon be removed anyways. But here I'll quickly add the style parameter to my text items to set some color and manually set this to color as white, because again, this will be gone soon anyways. And then we can copy this to all these text widgets here, just so to make sure that the text is a bit easier to see. And we can indeed see that we now got this grid. The styling definitely isn't finished, but we can see the 2-column layout along which the different grid items are positioned. So that's good. Now it's time for the actual category data. So the goal now is to replace these dummy text widgets with the actual category data and widgets that present that category data. And for that, first of all, in the lib folder, I'll add a new models folder because I'll add a new file that contains the blueprint for the category objects with which we'll work. So I'll name this file in there category.dart. And in this category.dart file, I'll add a new class, category, which is not a widget, but just a blueprint for a regular object. And here I'll define how a category in this app should look like, how it should be structured. And of course, there are different ways of defining this, but for this app here, a category should have an ID, which should be a string. It should have a title, which is also a string. And it should have a color, which is of type color. So that's a Flutter specific type, and therefore we should import material.dart by importing package Flutter material Dart as we did it many times before. That's how a category should in general be structured. And of course, I'll also add a constructor function here, a const constructor function, which will be used to initialize these objects and set these properties. So in here, I expect to get an ID. I also expect to get a title. And I want to have a color, but there I'll actually set a default color of color orange. Like this, so that if no color would be provided, this fallback default color would be used. So that's how for this app a category should be defined. And with that defined, we can add some dummy data. For this, also in the lib folder, I'll add a data folder, and in there I'll add a new file, which I'll name dummy_data.dart. And in this file, I want to store some dummy categories, which we'll use for this demo app. And attached, you find my dummy.dart file that contains some predefined categories. So here I got a bunch of categories, and we must add an import to our category model to make this work, though the attached file already includes this import. There you just have to make sure that the project name in this import path matches your project name. But with that, we're importing the category model, and we're setting up all these categories, and we also need to import the material.dart file from Flutter, but again, this will also be already the case if you're using the attached dummy.dart file. And in there, in this dummy.dart file, you see that a bunch of categories are created, all with IDs and titles and colors. And it's these categories here that should now be output on the categories screen that is defined in the categories Dart file. Now to output these categories in this categories screen, I'll add another new folder in my lib folder next to data and models, which I'll name widgets. And the idea here is that I put all non-screen widgets into this widgets folder. And therefore I'll actually create another folder on the same level as data, models, and widgets, which I'll name screens, because all my screen widgets should now go in there. So I'll move the category start file into the screens folder, and in the widgets folder, I'll create a new category grid item.dart file. And this is simply a file that will contain a widget which we'll then use in this grid for a single category. So that we don't end up with one huge widget here, but we instead outsource the category grid item logic into a separate widget. So with that, in the category grid item.dart file, we have to create a new class for this category grid item, so for this widget. And this does not have a screen because it won't act as a screen. But it should of course extend stateful or stateless widget, and indeed here we will have a widget that will not need to manage any internal state. And therefore this can and should be a stateless widget, and of course you must add that material Dart import as always. And we have to add this build method and also, as always, of course, our constructor function here. Now we should accept and forward the key parameter, but in addition, this class here, this widget class, should also accept some external data that will be required to output the actual category information. Indeed, in here, I simply expect to get the category for which I want to display information as an input of type category, and therefore you must make sure that you add the correct import to your own project package, and then there to models category Dart, so that this category type is available because the category class is defined in that file. And of course then here I also expect to get this data as an input. Here I'll expect it as a named parameter, but as always you could also go for a positional parameter instead. But here I'll go for a required named parameter, which also has the name category and is then automatically set to this property. And with that we can return our widget combination for this category grid item widget. A combination that should simply display the category title, use its color, and also make sure that the item will be tappable so that later we can navigate to a different screen, because ultimately that's what this section is about. So here I'll start by returning a container, and I'm using container because the container widget gives me a lot of options for setting the background color or background decoration in general for this widget. And that is indeed something I'll need to do here. I want to set the decoration parameter that is supported by container and set it to a box decoration object created with help of the box decoration class, which is provided by Flutter. And I'm using this class here because with that I can create a gradient, as we did it before in this course. And therefore, as always, also feel free to pause this video or also the other videos in this section to sometimes try out the next steps on your own. Because here my goal now is to create a linear gradient that uses the category color to transition from one variation of that color, which is simply the color with some opacity, to a different variation. So the same color without or with less opacity. And I'll do this here by creating a linear gradient and setting the colors parameter to a list of colors. And now my first color will be my category color with some opacity. Here I'll go for an opacity of 0.55. And my target color will be the same color, but with less opacity, so that we'll get a nice subtle gradient effect in the end. And I'll have a target opacity of 0.9 here. Now we can also configure this gradient and define where it begins and ends, as you learned. And here I'll make it begin by setting alignment to top left and set end to alignment bottom right. And of course, I also need to add a comma here. So with that, I'm adding a decoration to this container, but that's not all. The container also should get a child, hence we should set the child parameter on the container. And the child is simply the widget that will be placed inside of the container. And here I want to have the text widget with the category title as a text, but also with some styling applied. And here for the styling, I'll use my theme with theme off, as you learned it in the theming course section, to reach out to the text theme, and then there the title large theme. I want to apply the styling of the title large theme in the end. But I'll then copy this with some extra settings, though for that I must add an exclamation mark here to tell Dart that the title large text theme will be defined, which it will be since I'm using this Google Fonts defined text theme here, which does define text themes for all the different text variations. So this will work. But with that, I can copy this default text theme. And then here, I just want to change the color and set that to theme of context, color scheme, to access the color scheme that was inferred by Flutter based on some base color that I set in main Dart. This base color here. And then from that color scheme here, I'll choose the on background color. And you know it, you can and should always play around with things like this to try out different colors or different configurations so that you really get a good feeling for how Flutter works and how different widgets and objects can be configured in different ways. So that's the color I want to apply here. And with that added, there's just one last thing, for now at least. I want to add some padding to this container. And therefore, I'll set the padding parameter, which thankfully is supported by container, which makes container a quite versatile widget. And I'll set the padding to edge insets all 16 to add a padding of 16 pixels in all directions. And this is then a const object. With that, we can go to categories Dart, because there I want to use this category grid item which I just created. And we should delete those dummy text widgets now, and instead use the dummy categories that are defined in the dummy data file, and output those here in the categories screen in the categories Dart file. For this, in this list here, which is set as a value for children, we can use a for in loop to go through all the categories in available categories, which is the name of this constant value here in dummy data. And for that to work in this screen file, you of course must import the dummy data Dart file, which is in the data folder, into this file here. So this import here must be added. But with it added, you can go through all the categories. And we have to remove const now, since now we're deriving the list content dynamically. And when going through the categories here, you can then define the widget that should be output for every category. And here that will be the category grid item. And of course, category grid item is only available if you add this import here, where you import the category grid item Dart file, which is stored in the widgets folder into this file here. So with that imported, we can use this here. And it is also worth noting that using this for loop here is only an alternative to using available categories.map and then getting hold of every category like this and returning the category grid item like this in here, and then calling toList. So that would be the alternative to writing it like this. I mentioned this before, but it's really important to keep things like this in mind, which is why I'm mentioning it again here. So with that, we're outputting one category grid item per category in available categories, and we're passing the category as a value for the category parameter to this widget. And with that, if you then save this and force a reload, you should see these category items here. This is not entirely the final look I want to have, but it's a good start. This grid view is also scrollable by default, by the way, if we would exceed the available screen space here. But with that, we're almost there. I now just want to go back to the grid view and also set the padding parameter on that, which thankfully is supported, to also give this grid view some padding. And here I'll choose edge insets all 24 as a value, so that these items don't sit directly on the edges. And with that, this doesn't look too bad. We got these nice categories here. But of course, now I want to make sure that A, they have rounded corners, and B, more important, they are tappable. Because right now, if I tap them, nothing happens. And that, of course, needs to change. So let's now make sure that these grid items are tappable. And for that here, I'm going back to my category grid item Dart file. And in there, we can make this container or any other widget tappable by wrapping this widget that should be tappable with another widget. And that other widget would be the inkwell widget. Now actually, the inkwell widget is not just about making some child widget tappable. That could be achieved with the gesture detector widget as well. If you wrap a widget like this container with gesture detector, you can add a broad variety of listeners to it, for example on tap, but also many other listeners to listen to all kinds of user interactions with the child widget. But if you use inkwell instead, you can also add a on tap or many other listeners, as you can see. But in addition, you get a nice visual feedback if a user taps the item. With gesture detector, you would get no feedback. With inkwell, you do. And that's why I'm using inkwell. With inkwell wrapped around container, I can add the onTap parameter to set up a function that will be triggered whenever this item will be tapped. So with that, we already would be able to listen to events, but I'm not done yet. In addition, I'll set a splash color, which will be important for this visual tapping effect that we get. And I'll set this to theme of context primary color, to use one of my theme colors for that, or as a basis for this effect, to be precise. And we can also set a border radius here, which does not want a number, but instead a border radius object, which can be constructed in different ways. For example, by using the circular constructor, which allows us to define a radius like 16 to give these items some nice rounded corners. You can try out different values here to get exactly the look you want. So with that, these items should be tappable. Right now, nothing happens when we tap them, but they are tappable. And if we save this all and force a reload, we can see this effect in a very subtle way. If you tap and hold one of these items, you see it light up a little bit. But of course, we don't have the rounded corners, or at least we don't have the rounded corners on these items right now. If we tap one and hold this, the highlight effect indeed has rounded corners. So the missing thing here indeed only is to go to this container in our category grid item. And there in decoration, besides adding this gradient, I also want to add a border radius. And just as on the inkwell, this border radius should be set to border radius circular 16, like this. And with that, now we finally get these rounded corners and this nice highlight effect if we tap and hold. Of course, the next goal is to make sure that we can not just tap and hold, but that we actually navigate to a different screen if we tap one of these items. So the goal is to go to a different screen if one of these items is tapped, and therefore we should add a different screen. In the screens folder, I'll create a second file which I'll name meals.dart, because the goal with this screen is to show all the meals for a selected category. Now inside of meals.dart, we of course must create a new class, and I'll name it meals screen because it will be a widget that acts as a screen. And this will also extend stateless widget because there also won't be any state that would need to be managed in this screen later on. So meals screen like this it is. And of course we add build and we add our constructor function as we always do, forwarding that key. And for this screen, I will also need some input because I will need a list of all the meals that should be displayed for a given category. And for that, as a first step, we of course need meals because otherwise it will be hard to display them. So therefore back here in dummy data.dart, I want to add some dummy meal data, and for that in turn, I first of all want to add a new model in that models folder. I'll add a new file called meal.dart in which I want to define the structure for a single meal. So in there I'll add a new meal class, and since this would be a rather long class, you find my meal.dart file attached, and you should simply replace your meal.dart file in the models folder with the attached one, or simply replace the content. And if you did that, you will see that my meal.dart file contains this meal class, which actually has quite a long list of properties that are all set through named parameters. For example, for every meal we store a title, an image URL, the ingredients, which is a list of strings, and the steps, so basically the instructions on how to make that meal, which is also a list of strings, the duration, which is a number, and then also complexity and affordability, which are enums with some predefined choices or some predefined options, to put it like this. In addition, I also have some flags here that basically tell us whether a certain meal is gluten-free, lactose-free, vegan, or vegetarian. So that's how a meal will be defined in this app. And with that model added, we'll also update the dummy data.dart file. And you can simply use the one which you find attached and replace your dummy data.dart file with the attached one. And then again, make sure that your project name matches here in the import statements. And then you'll see that we still have all these categories here, but then also this list of dummy meals, where I use this newly added meal model to create a bunch of dummy meals, all with ingredients, instructions, and some links to images, though of course definitely feel free to set up your own meals here in addition. So with those meals added to the dummy data.dart file, we can go to the meals.dart file, and in there we now want to output that list of meals. Now, since this widget here will act as a screen widget, we also first of all should return a scaffold widget, so that we can, for example, set the app bar, which is exactly what I'll do here, so that I can set the title. And the title here should actually be set to the category that was selected. Therefore, in this meals screen, we should accept that title as input data. And I also want to accept my meals as input data. And that should be a list of meals using that meal model that we defined in the models folder. Hence, this import path here must be added. And of course, these two input values now also should be set when this widget is created. So here I will require a title to be provided, and I'll require the meals to be provided. And back down here in the build method, we can now set the title, well, as a title in the app bar, and set the body to this list in the end. So to a widget that outputs this list of meals. And that is of course also something you could try on your own. Try outputting this list of meals here, maybe in a way that offers good performance, even if we had a long list of meals. And also make sure to show some fallback text in case no meals should be available. So if we selected a category that has no meals, for example, definitely try this on your own. Thereafter, we'll implement this together. So, did you succeed? Let's now build this together. And for this here, in this scaffold body, I'll use Flutter's list view builder constructor here to create a scrollable list view that makes sure that only items that are actually visible will be displayed, to optimize performance for scenarios where we might have very long lists. So here we then must pass a value for item builder, and that, as you learned, should be a function that takes context and an index. And then this simply builds all these list items, and for every list item that gets built here, I want to output the meal information. In this case here, for the moment, simply a text widget that outputs the name of the meal. For this, I'll access my meals list and then one specific meal by index, and then simply the title, like this. Now, of course, we also could have a scenario where we got no meals, and therefore to handle this as well, I will actually add an if statement here to my build method, where I check if meals is empty, so if I get an empty list of meals here. And in this case, I want to set my body to something different. Therefore, I'll add a new variable of type widget, which defines my content or body, however you want to name it. I'll go for content. And here I'll set this to this list view here, like this. But if my meals are empty, I'll instead set content equal to the center widget, where I then output a child. And here my child will be a column, where I set the main axis size to min, so that this column really is centered and is not unconstrained vertically. And the children of the column here are two text widgets in the end. The first text widget simply says, uh-oh, nothing here. And then I have a sized box for spacing with a height of 16. And these two widgets here can be turned into constant objects. And then I want to have another text widget where I could say, try selecting a different category. And here I now actually want to apply a specific style with theme of, and then I'll access the text theme and use the body large text variant to then copy it with that exclamation mark in front of it to tell Dart that this text variation will be defined in this theme. So to copy it with a different color, that's the goal here in the end. I'll use a different color, and the color I want to use here will also be taken from the theme, and they are from the color scheme, and it should be the on background color. And to make sure that I get some auto formatting here and this becomes readable again, I'll quickly set this content as a value for body down here in the scaffold, so that I got no more errors in this code file. And now after formatting the code, this is in the end how my content looks like if my meals are empty. I'm outputting this text here, and I indeed also want to apply some styling to the first text. So I'll copy over this style parameter with its value, but here I will access headline large, so a different predefined text variant, but then also set this text's color to the on background color. And this now can't be const anymore since I'm deriving some theming data dynamically. Now, of course, these exact styles, as always, are up to you. And we could also switch the order here, by the way, and set this here as our default value for content, and set this list view here as a value if meals is not empty, so if we have meals. But ultimately, this is up to you. I'll go for this default here though and output my content. And now to see whether or not that worked, I'll go to the main Dart file, and temporarily I'll replace the categories screen there with the meals screen. And of course, for that, you must import the meals screen, the meals.dart file from the screens folder. And then on that screen, you of course have to pass a value for title, like for example, some category. And soon this will be dynamic, but for the moment, I'll just hard code some dummy data. And then the meals, which we could set to an empty list to see whether our fallback content is displayed correctly. So let's see whether that works. If I restart this, looks good. Or to show the actual meals that we have. And for that, it's worth noting that in dummy data, the meals list has a name of dummy meals. So in the end, it's this list which I want to use in main Dart now, dummy meals. And for this to work, you must import the dummy-data.dart file into this main.dart file. But with this set, we should be able to output the list, though I'm getting an error here because indeed I forgot in the meals.dart file on this list view to tell Flutter how many items I'll have, and therefore I'm getting an error. Indeed, here we should set the item count and set it to meals.length. So this line of code here is important to make sure that Flutter renders the list view correctly. With that, it works and the styling is off, but it's also not the final styling, but we can see some meal titles here. A bit hard to read, but again, this is not final yet. We'll of course improve this. But the general logic works. So now that we can go to the meals screen, it's of course time to populate it with the actual data for the selected meal. And therefore here in select category, we should make sure that we load the meals that belong to the selected category. For this, as a first step, we should accept a second parameter here, which is the category that was selected, because without this information, it will be quite difficult to find the meals that belong to a certain category. So therefore here, we should make sure that we actually import this category model from the category Dart file in the models folder. And we accept this parameter. And then here in select category, we should reach out to all our dummy meals and use the built-in where method, which is supported on all lists in Dart, to filter this dummy meals list. Because where essentially returns a new iterable, but that, as you learned, basically is a list that only contains the items that match a certain condition. So to where you pass a function which will be executed automatically by Dart on every item in the list on which where is called, so on dummy meals. So here we get the individual meal items, because this function will be executed once per meal in that dummy meals list. And we should return true if we want to keep that meal, or false if we don't want to keep it in that newly created list that will be returned by where. Now to define a fitting condition here, let's take a brief look at the meals again. And here it's important to note that every meal has a categories property, which is a list of strings, and in the end it's a list of category IDs. So the categories have IDs like C4, C5, and so on, and in categories in our meals, we have those IDs. And every meals has different category IDs to which it is mapped. So therefore here in categories screen, where I want to filter my meals, I can take a look at my meal categories and check whether it contains, which is another built-in method available on lists, to check whether a list contains a certain value. And here I'll check whether meal categories contains the category ID of the category that was selected here. And that will return true if this meal for which this function is currently executed does include that category ID, and false otherwise. And therefore the list returned by where will only include meals that do have this category ID added to them. So here I'll then call toList to convert this iterable returned by where to a real list and store it in a variable filtered meals, or however you want to call it. And in the end, it's now this filtered meals list that's passed as a value to the meals parameter on the meals screen. And the title, of course, can now also be set dynamically. And it should be set to the category title, so we can use this category parameter down here to access category.title. And with that, we should be able to load the actual category and meals data for the category that was selected. Of course, now we just must make sure that this category parameter is also provided when select category is executed. So therefore down here, where we're calling select category, besides passing in the context, we now also must pass in the category, but thankfully this category is available here. In this loop here, it's available there, so therefore we can set or pass this category here as a value to select category. If you now save this and force a reload, if you click a category, you can see the title indeed was used here, and even though it's hard to see, the meals here are now also filtered, and we don't have all the meals being output here. And different categories show different titles and a different list of meals. And of course, with that, it's now also finally time to fix the way these meals are displayed here and make sure that they are actually displayed how they should be displayed. So we're making good progress here, but right now the metadata is missing. The metadata which I wanted to display below all these meal titles. And for this, I have this row here, but of course at the moment this row is empty. Now my goal is to output the duration, the complexity, and the affordability of every meal in that row. And if you take a look at the dummy data again, this is all data we are storing in there. Affordability, complexity, and duration. Affordability and complexity are enum values, and duration is simply an integer. So we have this data, we now just need to output it here. Now for every metadata item in this row here, I plan to have an icon with some text next to it. And since I will repeat that same combination of icon and text 3 times, it makes sense to create a custom widget here, which we can repeat, instead of copy and pasting a bunch of code. And therefore I'll create a new widget here, meal item trait.dart is the file name. And in there I have my meal item trait class, which extends stateless widget because we won't need to manage any state in here. And we should import material.dart here. And then as always, we have the build method and then our constructor function, meal item trait. And we'll get some input data here. To be precise, I expect to get the icon that should be displayed, which should be of type icon data, because that is the kind of data the built-in icon widget wants later on. And I want to get a string, the label, that should be shown next to the icon. And here in the build method, I then want to output a row which has this icon as a first widget, then a sized box for some spacing, and then a text widget that displays the label. Now for that, of course, in this constructor, we should accept and forward the key parameter, but then also require and set the icon and the label, like this. And with this all accepted and set, we can use it down here. For example, with the built-in icon widget, this, as mentioned, wants an icon data value as a first positional argument. So therefore here I can use this icon, which we have as a property and which we're getting as a parameter, as a value here. And I'll actually also give this icon a fixed size by setting the size parameter that's accepted by the built-in icon widget and set this to 17. And I'll set the color of the icon to white, like this. Now for the sized box, I simply want to have some width between icon and text, so some spacing, and I'll set this to a width of 6. And for the text, this of course should output the label, but here I'll then also add some styling, some text style, where I simply want to ensure that we always have some white text here, so that this label is always white. And this can be turned into a constant object here. And that's already all. This is my meal item trait widget, which I can now reuse inside of the meal item Dart file. Here in this row at the bottom, I'll add a first meal item trait. And of course, as always, for that you should make sure that you import this meal item trait.dart file in which we just worked. And then here we can set an icon and then a label. Now the first piece of metadata which I want to output here is the duration. And for that I think the schedule icon is quite good, because that's this little clock icon here. Well, and then the label is the meal duration, but that, as mentioned before, is an integer, and of course label wants a string, and therefore we have to convert this to a string either by calling toString, or what I'll actually do here, by wrapping this with single quotes and then using this injection syntax here, about which you learned earlier, which also allows me to then add a blank and then min for minutes thereafter, to make this a bit more meaningful and useful to the users of our app. So that's my first meal item trait being used here. If I save this and reload, you therefore see this item here below the title. And you see that for all the meals, of course. Now, by the way, you might be wondering why here we can use a row, which my meal item trait returns in the end, inside of another row. Normally we would get an error and we would need to use expanded, right? Well, here it works without expanded because this row is inside of a column which is inside of this positioned widget, which has left and right set to 0. Therefore, this positioned widget enforces its child, the container, to take exactly that width between the left border of this stack and the right border of this stack. And therefore, we actually have a fixed width, and this fixed width is passed down from the container to the column and from the column to this row. So therefore this row here is not unconstrained horizontally, and hence it has no problem with another row being inside of it, because even though this row here is unconstrained horizontally, there is a maximum width applied by this row to this meal item trait here. That's how this works here. So that's the first piece of metadata being output here. Then I'll add a sized box here for some spacing with a width of, let's say, 12. And then the next meal item trait. But here I'm not outputting the duration, but instead the complexity. And I think here the work item is a good choice. Now here I therefore want to output the complexity, but the complexity is an enum. And if we take a look at the dummy data, we see that it, for example, is a complexity of simple. Now I'm fine with using this as a text, but I want to make sure that it starts with an uppercase character instead of a lowercase character. And to ensure that this is the case, we need to transform this text here. And for that, I'll add a simple getter to my meal item class here, a getter that will return a string, and a getter which I'll name complexity text without these parentheses here. And in there we can now return meal.complexity.name, because name gives you access to the enum value as a string. And I'll access the first character by using square brackets 0 here, which is a notation you know from lists. This accesses the first list item. Well, turns out that you can use the same notation on string to access the different characters. So this is used to access the first character in a string, because just as in lists, the character indexes start at 0. And now we can call the built-in toUppercase method on this first character to transform it to uppercase. But of course now we would return only the first character in uppercase. And that's of course not what I want. I still want to return the entire word in the end. So therefore we have to combine this uppercase first character with the rest of the word. And we can do this with the plus operator. You know this operator from mathematical operations, but it can indeed also be used with strings to concatenate two strings. For example, hello plus world would yield hello world, like this. So therefore here I want to concatenate this uppercase character with the rest of this word. So I'll again access meal complexity name. And now to get the word without the first character, we can use the built-in substring method, which is a method that's built into Dart and available on all strings. And substring simply returns a part of a string, starting at start and potentially ending at end, where start and end are string indexes. So here, since strings start at index 0, I pass 1 as a value because I don't want to start at the first character, but at the second character, since the first character is converted to uppercase here, and I then want to append the rest of the word starting at the second character. So that's how we can transform this complexity text, and then we can use this complexity text down there. So instead of accessing meal.complexity, I access complexity text. And now we can actually get rid of these curly braces here, since we now have a simple variable or property that we're accessing here instead of a more complex expression. Well, and now we can repeat that and again add a sized box with the width set to 12, and then one last meal item trait where I'll choose an icon of attach money, which is this icon here, to output the affordability of the meal. And this is also an enum and therefore should be transformed in the same way. So therefore I'll just copy this code from there and create a new getter called affordability text. And here I access meal.affordability. And I also do this here. And with that we got this affordability text, which now is output in that last meal item trait item. And of course, I also want to get rid of min here, because we don't need that. And therefore, we can actually get rid of this entire injection syntax, because we don't need it anymore, because I just want to output the complexity or affordability texts. Well, and with that, finally, if we save this, you will see that if you restart this, now you got all these metadata items below the title of the meal. Now, as a last step, I want to make sure that this metadata is centered, because right now it's clearly not centered below the title. And to achieve this, in my metadata row here, I'll add a main axis alignment of main axis alignment center. The main axis in a row is from left to right, so this will center the items horizontally. And with that, this now looks much better. So now it's time to make sure that we can also tap those items and then navigate to the meal detail screen. So now that we do have these meal items here, it's time to make sure that we can also go to a meal detail page so that we can tap such a meal and be taken there. And this is a great practice for you because it's essentially a similar process to what we did to get from categories to this list of meals. I want you to add the code to this project that allows users to tap those meal items and gets them to a meal detail screen. Of course, you have yet to add this meal detail screen, and for the moment it doesn't have to be too fancy. Just make sure that you output the meal title in the app bar, and then below that the meal image, and we'll then work on the rest of this details screen together thereafter. But first, give it a try on your own. So, did you succeed? Let's build this together, and let's make sure that users can tap those meal items to be taken to the meal detail screen. Now for this, as mentioned, we first of all have to add such a meal details screen, which is what I'm doing here, adding a new file in that screens folder called meal details. And then in there, we have the meal details class. And just as before, here we can extend stateless widget like this, because indeed here we won't need to manage any state. And we need our build method, and then of course also our constructor, meal details like this, where we get and forward the key. And for the moment, this will be a stateless widget. Later, we'll turn this into a stateful widget, but for the moment, we just need a stateless widget. Now here we'll also need to store some data. We'll need to get some data to output those meal details. And to be precise, we of course need the meal. So the meal, which should be of type meal, and for that, of course, you must import the meal model file. Then, of course, we also have to make sure that we get this meal parameter and store the value received on that parameter in this meal property. Now that we got that meal, we can return our scaffold here because we have a brand new screen, as mentioned. And in this scaffold, I want to have an app bar using Flutter's app bar widget, where the title is set to a text widget where I output the title of the meal that was selected, so of this meal here. Now, besides the app bar, we of course also have a body in that scaffold. And for the moment, as mentioned, it's enough if we simply output the image of that meal here. For that, we can use Flutter's image widget. And as you learned earlier in the course, this widget has various constructor functions that allow us to load images from different sources. And here I need image network since, as mentioned earlier, our images are in the end URLs to images that are stored somewhere in the internet. And image network loads these images from those places and then displays them in this app. So here we got image network. And then I can access meal.image URL here to set the URL for this image. Now, in addition, I want to assign a width of double infinity to make sure that we take all the available space. And I'll give this a height of, let's say, 300, and then add fit box fit cover to make sure that the image is sized appropriately, but not distorted. And with that, we're outputting this image here. The rest will follow later. But with that, we got the meal details screen, as it should actually be called, since we'll use this widget as a screen. So to be consistent with my other widget names, this should be meal details screen. And with that added here, we can go back to the meal start file, where we have the meals screen, which displays all the meals. And there we want to make sure that if a single meal item here is tapped, we go to the meal details screen. Now for that, of course, inside of that meal item widget, we have our inkwell, which allows us to register a function for the tap event. So whenever a user taps on this item. Now here in the end, in this meal item widget, I don't want to handle the tap, but instead I just want to get a function as an additional property. So a function here, which gets the meal on which I tapped as an input, and which will be stored in a property called onSelectMeal, for example. And of course, we then must make sure that this property is set when the class is instantiated, like this. And it's then onSelectMeal that should be connected to the inkwell. So that's set as a value for the onTap parameter. This, however, doesn't work because onTap does not provide such a meal, and onSelectMeal is a function that wants to get a meal, and therefore here I'll set onTap equal to an anonymous function, and in there we can manually execute onSelectMeal and then pass our meal as a value to onSelectMeal. And this meal which I am passing as a value here is this meal property. With that, in the meals.dart file, where I'm outputting these meal items, I now have to set this onSelectMeal parameter, which we just added to the meal item widget. So therefore here in meals.dart, I want to add a new function, which could be named select meal. And this should get the selected meal as an input. And that's in line with the parameter we just added in meal item, because that wants a function that gets a meal as an input. And we're now creating such a function in the meal start file. This function here, it takes a meal as an input. And in there, I then again want to use the navigator built into Flutter of context. And therefore, we'll have to make sure that I actually also get my build context here, like this. And then we can again call push here to push a new screen onto our stack of screens. And this new screen here is the meal details screen, though, as you learned, not passed into push like this, but instead wrapped in such a material page route, which has this builder where we get the context and where we then return our meal details screen like this. And now it's select meal, which I in the end want to use down here as a value for onSelect meal, though it is worth noting that select meal now of course is a function that does not just get a meal, but also a context. So now we could either edit meal item Dart and make sure that here we also accept a context in our type definition. And then we would need to pass a context down here when we call onSelect meal. Or alternatively, in meal start, we don't set select meal as a value for onSelect meal, but instead we set another function as a value here, which gets a meal, because inside of meal item, where we are calling this function in the end, we do pass such a meal. But then here we manually call select meal, and we kind of forward that meal that we're getting here, but we're also passing the context to select meal, and the context here is available since we're inside of the build method, where we do have this context. And that's how I will do it here. So we call select meal here in this place inside of meals Dart, forwarding that meal, which we get from inside meal item. And then in select meal, we're pushing our meal details screen as a route onto our stack of screens. Well, and that should be all that needs to be done. If we now save this and force a reload, we should be able to select a category and then a meal. And as you can see, I'm taken to that newly added meal details screen. And of course, we still automatically get this back button, which we can then use to go back and pop screens off that stack of screens. But that's how this forward-backward navigation works in the end, simply by using navigator push. And if we ever would want to pop a screen off manually, for example because some button was clicked, we could of course always do that by using navigator of context pop. Or alternatively, as we did it before, navigator pop and passing the context to it. We don't need to do this here, but that is how you could manually go back to the previous screen. So now that we got the basic navigation set up, it's time to work on this meal details screen, because of course that screen is not finished yet. At the moment, I'm only outputting my image and my title here, and that's not enough. Instead, this image here should just be the topmost element on this screen, right below the title and the app bar. But below the image, I then want to have a list of ingredients and a list of step-by-step instructions. And therefore, here in the meal details screen widget, I'll put this image here into a column widget, since we now won't just have one single widget here as a body, but multiple widgets. And the image is just one of them. So I'll cut that and paste it in here. And now below that image, I want to have my ingredients. Now for that, I'll start by adding a sized box to have some spacing between the image and the next section. And I'll give this a height of, let's say, 14. And then I'll add a text widget, which kind of acts as a title for the next section of this screen. And the next section will be my list of ingredients, hence here I'll give this a title of ingredients. And this can simply be hard-coded like this. Now I want to adjust the styling, and for that I'll set the style to a style that's taken from my theme. So I'll access theme of context text theme, and here I want to access the title large style. Now I will add this exclamation mark to tell Dart that this will exist, so that then I can call copy with on that title large text variant. And now this also can't be const anymore, by the way. So now that I copy this, I then want to override the color and set this equal to theme of context color scheme like this, and there choose on background as a color. So that's now the title for the next section. Below that title, I then want to output all the ingredients of the selected meal. And if you take another look at the dummy data, you will see that the ingredients is in the end just a list of strings, just as the steps will be a list of strings thereafter. So therefore here we can create a for loop to loop through all the ingredients. So for final ingredient in meal.ingredients, this is how we can go through all the ingredients here. And I'm using this for loop syntax that can be used inside of a list, this list here, to add items to it. And the item I want to add for every ingredient here is a text widget where I output the ingredient. Because again, meal ingredients is a list of strings, so here I'm outputting a string. If I save this and I select a meal, you now see the title ingredients here, and below that some ingredients, which of course are not readable though. So in order to make this readable, I'll copy the style setup here from my ingredients title and add this here to this text. But here I don't want to use title large as a base style, but instead body medium. And of course you can play around with different styles here to find the one you personally like most. Now I think some spacing between this ingredients title and the actual ingredients would also be nice to have. Therefore, before this for loop, I'll add a sized box with a height of 14 maybe, so that we have some spacing here. And I'd say that looks quite decent. And I think it might look even a bit better if we go back to this title here and change the color from on background to primary, so that the title is highlighted like this. We can even make it bold by also setting font weight to font weight bold here, to make the title stand out a bit more. And with that, I'm outputting my ingredients. Now, in addition to the ingredients, I of course also want to output the step-by-step instructions, and therefore we can again add a sized box below this for loop here, and here maybe add a space of 24 pixels. Before we then copy and paste this title, we could also put it into a separate widget, but here, since it's not a lot of code and I'm only repeating it once, I'm just copy and pasting it. So I'm outputting it here, and then I'll say steps. And then I'll copy and paste this loop. Again, we could put it into a separate widget, but here I'll just copy and paste it. And actually I'll copy and paste it together with this sized box, which we added between title and loop, to add this here below this steps title. And here, of course, I don't go through meal ingredients, but through meal steps. And here I have my individual step, which is then output like this. If we now save this, we got the steps here, and this of course looks ugly and is not that easy to read, so here I definitely want to fine-tune this. To improve the looks of that, I'll go to that text and add a text alignment of text align center, so that's not inside of the style, but added directly to the text widget. And in addition, I'll wrap this text widget with some padding, some symmetric padding though, where horizontally I want to have a padding of, let's say, 12, but vertically I want to have a padding of 16. And now I'm getting a warning here because now I'm actually exceeding the available screen height, but I'll fix this in a second. If we take a look at it, this looks better, though now it's actually too much space. So let's actually switch from vertical 16 to vertical 8. And nonetheless, I get this warning, but now I think this looks a bit better. Now to fix the warning, we have to make sure that this entire screen here is scrollable. And to make sure that it's scrollable, we can wrap this column here with single child scroll view, as we did before in the course, or we replace it with list view. Not list view builder, because here I actually won't have a super long list of items, but list view to get this automatic scrolling. So now with that you see it is scrollable. Now my titles and the ingredients are pushed all the way to the left though, because unlike column they're not centered by default. And therefore here I'll instead go back to column and wrap this with another widget with that single child scroll view widget I mentioned before, since this will make sure that the content stays centered. And with that here I can now scroll and my content is centered, which I would say looks better. And with that, we finished this details screen. Now we're actually going to come back to it a little bit later and add more features to it, because you should be able to mark meals as favorites, and this is a feature which we will add later, but for the moment it's finished. And we can now dive into another navigation pattern, and that would be tabs and having a tab bar at the bottom. So now that we got this forward, backward navigation working and we can view our meal details, it's time to add another very important navigation pattern to this app. A pattern which you will likely need in many of the apps you're going to build in the future. And that pattern would be tab-based navigation, having a tab bar at the bottom which can be used to switch between different screens. That's what we're going to add here, and we're going to add it to allow users to switch between this categories screen here, where they then can dive into categories and meals, and a favorites screen where they can view all their favorite meals and then still dive into those meals, but they don't have the categories, they just have their favorite meals there. That's the idea, and that's what we're going to build here. Now for that, we first of all have to add a new screen, a new file in the screens folder, and that new screen will be called tabs. Because this tabs navigation requires its own screen, which then loads other screens as embedded screens, you could say. Now in this tabs Dart file, we therefore create a new class, because we'll still have a widget. But here we have to extend stateful widget for the first time in this section, because switching between these tabs, which we'll soon add, will require us to update some state to update what's visible on the screen. Because if we switch from tab A to tab B, we of course must update the screen. So here I create a new stateful widget class, and of course we'll also create the state class that belongs to it, where we extend state that is connected to our tabs screen widget. And in this tabs screen widget, we have the create state method, where we return an instance of our tabs screen state, like this. And here we can change this to state of tabs screen. We will also add a constructor here, which in this case is a very simple constructor that only accepts and forwards this key. And then in the tabs screen state class down there, we of course need to add the build method, as we always do. And in this build method here, we will return a scaffold with an app bar, which is set to the app bar widget, where I want to set the title dynamically. It should always be a text widget, but the text that is displayed as a title should depend on which tab is selected. So I'll just put dynamic here and we'll replace this later. Now, of course, we'll also have a body, and this also will need to be set dynamically, because that will be the active screen, which will depend on which tab is selected. So here I'll just add 3 dots for now, and we're going to work on this later as well. Because now we're also going to add something new. We're going to add the bottom navigation bar parameter to the scaffold widget. Because this tab bar is such a common thing, such a common requirement in mobile apps, that it's officially supported by Flutter. The scaffold widget allows you to set a bottom navigation bar, which in the end simply is such a tab bar. Now here, bottom navigation bar wants a widget, but typically here you create a bottom navigation bar widget, and that's another widget built into Flutter. Now, bottom navigation bar is a widget that, for example, has an onTap parameter, which wants a function that will be triggered automatically whenever the user selects a tab. So whenever the user taps one of the items in this tab bar. Now for this, onTap will call a function that automatically receives an integer as a value. The index of the tab that was tapped, to be precise. So here we should provide a function that accepts this index, and again the index value will be provided by Flutter, since it will be Flutter that calls this function when the user taps one of our tabs. And then we also have to add items to this bottom navigation bar, which is a list of tabs in the end. Now a tab here is a bottom navigation bar item object, and those objects can be created with help of the built-in bottom navigation bar item class. Now every bottom navigation bar item needs an icon, and in addition you can also set a label. Now here I'll need 2 tabs, one for the categories screen and one for the favorites screen, which we have yet to add. Now here I'll start with the icon for the categories screen. You can of course use any icon of your choice, but here I'll build one with the built-in icon widget, because icon wants a widget, but of course it typically wants an icon widget. And the icon I want to use here with this icon widget is the set meal icon, which is built into Flutter and which looks like this. Now the label here should just be a string, and here I'll use a label of categories, because with this tab the user will go to the categories screen. Now for the second bottom navigation bar item, I'll create an icon with the star icon, which looks like this, because here we'll go to the favorites that were selected by the user. Now here we can then add const in front of this list, since both items are const and can't change in any way. We can of course change which one was selected, but the tab widgets themselves internally don't change. And now we can set our body. And of course that body should be set dynamically based on which tab was pressed. So therefore what I'll do here in my tabs screen state class is I'll add a new variable, which is of type int, which I'll name selected page index. And initially I'll set that to 0. Now I'll have 2 pages, and I simply plan to work with the index as 0 for the first page and 1 for the second page. Now with that state added, I can also add a method that can be called select page, where I get an index as an input, and where I then call set state to update my selected page index and set it to the index I get as an argument here. And it's now select page, which I'll connect to my bottom navigation bar as a value for onTap. So that whenever we tab one of these tabs, we trigger select page and we update the selected page index. Now, how is this page index useful? Well, here in the build method, we can now create a new variable, active page, which is of type widget. And by default, this could be the categories screen, like this. And we can set this to const here. But now I can check if the selected page index is 1, so if the second tab was selected, and keep in mind the second tab should lead us to the favorites, so if this index is 1, then I want to set active page to a different screen. And indeed, the screen to which I want to set it is the meals screen. Now, we used the meals screen before to get there from inside the categories screen. And that won't change. We will still push this meals screen from inside there. But the favorites screen can simply reuse the meals screen, because on the favorites screen, I in the end just want to display a bunch of meals. And that is exactly what the meals screen does. So reusing that screen makes a lot of sense. Therefore, if the selected page index is 1, so if this second tab, this favorites tab was pressed, my active page should be the meals screen. And of course, for categories screen and meals screen to be available in this file, you have to add imports to both screens. So from the screens folder in your project, you have to import category start and meal start. But with that imported, you can set these screens as values for active page. And now for the meals screen, we also have to set the title and the meals. And the title here should be favorites, though I will come back to that a little bit later. But for the moment, it's favorites. And for the meals, we of course want to show just the favorite meals of the user. Now, at the moment, we got no logic for managing favorites, and therefore for the moment, I'll just show an empty list here, like this. But this will change later. But now we have the logic for switching between two different screens, and now we can use active page, which contains one of these two screens, as a value for body. And with that, we got the logic to change the index, and based on the index, we change the screen, which we output as body here. Now we can also set this title here dynamically by adding another variable, active page title, which by default is categories, for example. But if the selected page index is 1, we can set active page title equal to favorites or your favorites. And it's now this active page title that will be output here in this text widget in the app bar as a title. And now with all these steps taken, we can go to the main Dart file and make sure that by default we don't show the categories screen, but instead the newly added tabs screen. And for that, of course, you can remove the categories screen import, but make sure that you added the tabs screen import like this. If you now save everything and force a reload, you should have some tabs at the bottom here. And by default, the first tab is selected. Now, if I click the second tab, you see that indeed I switch to the favorites screen. But you might also see that indeed the second tab is now not highlighted. It's still the first tab, which I can tap to go back, but the highlighting of the tab never changes. The reason for that is that we actually have to tell the bottom navigation bar which tab is selected. And this is done by setting another parameter. And indeed, bottom navigation bar has many parameters that can be set to configure this navigation bar exactly as you want it. But here we have to set the current index and set this to our selected page index, because this will simply control which tab will be highlighted. And we want to keep this in sync with our state, with the selected page index state. Once you made this change here, you can go back and you will see that now the tabs are selected and highlighted correctly. And that is in general how you can add tab-based navigation. But at the moment, we actually have a problem, at least a potential problem. We have two app bars here. also of course on the favorites screen. And this of course is not ideal. So why do we have these two tab bars? Well, we have them because we have a scaffold widget here in the tabs screen, but we then also have a scaffold widget in the categories screen here, where we also add a tab bar, and in the meals screen, where we also add a tab bar. Now for the categories screen, the solution is quite straightforward. We should simply go to categories Dart and remove the scaffold there, because we are setting a title for this screen inside of the tabs screen. There we are managing this active page title, which is set as a title for the overall screen. So in categories Dart, we can remove this scaffold here with the app bar and body, and remove one closing parenthesis so that we directly return the grid view. With that here on the categories screen, we now only have one tab bar and it still works as before. So that's all good. For the favorites screen, it's more difficult, because here we're using the meals screen and we can't just remove the scaffold widget there, because the meals screen is also used if we dive into categories. Here we got the meals screen as well, and here we need scaffold because it is a standalone screen without tabs at the bottom. Therefore we should conditionally use this scaffold widget. And one way of showing it conditionally would be to actually make this title optional by adding a question mark after string so that it can also be null. Then we can also remove required here so that the title does not have to be set. With that down there, we can actually add some conditional logic and check if title is null, so if it's not set, and if that's the case, we just return our content. Otherwise, we return the scaffold that uses the title, and here we can add an exclamation mark because we know that if we reach this code here and this code gets executed, title will not be null, because if it would be null, we would return here. And as you learned, once you return, any other code thereafter won't be executed. So we either return content, which is simply our list or this fallback text here, or we return the scaffold with the app bar. And now we can go back to the tabs screen, and here, when creating the meals screen, we now simply don't set the title, we just set the meals. And we can set this to const for now, but we don't set the title there, and by not setting the title, we will make sure that this scaffold inside of meals screen won't be displayed. So now if we reload, you will see that if you switch to favorites, there is only one app bar up there. And on the other hand, if we dive into a category, we still have the app bar there as well. So here we still got the scaffold. Now that we got the tabs working, we can also work on this favorites feature. And for that, it should be possible to visit this meal details screen. And here I want to have a button that allows me to mark this meal as a favorite. And to allow users to mark a meal as an item, I'll go to this meal details Dart file where we have the meal details screen. And there in the app bar, I want to add some actions, or one action to be precise. I want to add an icon button as an action, which can be used to mark a meal as a favorite. Now for that, of course, we'll have to do something once this is pressed, but then we also have to add an icon here. And the icon should actually change based on whether this meal already is a favorite or not. For a start, I'll simply create an icon widget here, which is set to icons.star. And we can set this to const, though we will change this logic later anyways. Now with that, we'll have this icon here at the top, which is nice. And when we tap this button, this meal here should either be saved as a favorite or should be removed from the favorites list. And this, of course, means that we need to manage some state somewhere in this application. We need to manage a list of meals or meal IDs or anything like that that have been marked as favorite. But where should we manage this list? Well, not inside of this meal details screen, because if we would manage this state in here, we would not have access to it from inside other widgets. And we do need this information, which meals are a favorite or not, in the tabs screen, for example, because here we are displaying the meals screen and we're passing the meals that should be rendered on that meals screen to it. And since we're rendering the meals screen as the favorites screen here, in the end, we want to pass all the favorite meals to the meals screen in this place. So therefore, we need access to the information which meals are marked as favorites in this tabs screen widget. Of course, the state is manipulated from inside meal details though. So therefore, we'll have to make sure that we create a function that adds or removes favorites here in tabs screen state, but we'll have to pass this function down to meal details, so that when this icon button is pressed there, we actually change the state in the tabs screen. So we're lifting the state up in the end, something we have done many times before in this course and which we will do again here. So for that here, we can add a final list of meals, and it can be final because we'll never reassign this property, which I'm about to add here. And this property can be called favorite meals. And initially it's an empty list. And meal also should be imported, so you should add this import from the models folder. So this list is empty initially, but of course now we can add a new function, which could be called toggle meal favorite status, because this function should either add a meal to the list or remove the meal. It should be one function that does both. And here I expect to get a meal as a parameter. And then in this function, we need to find out whether this meal here is already part of this list, in which case it should be removed, or if it's not part, in which case it should be added. Now we can use different approaches to determine whether this meal is part of this list or not. And one simple, straightforward way of determining this is to add a variable isExisting. And in this variable, I want to store true or false, but of course that should be derived dynamically, which I can do by taking a look at favorite meals and then calling contains, a built-in method that you can call on any list, to check whether favorite meals contains this meal which I'm getting here. If it does, this will return true, otherwise it will return false. And now we can check if isExisting is true, or as a shortcut, we can also just write isExisting, since this already stores true or false, and if wants true or false. So that's all we have to write. Checking like this would be redundant. So here I'm checking if isExisting is true in the end. And if it is true, it means we have to remove the meal. So in this case, I want to access favorite meals and call remove and remove the meal. And otherwise, I'll access favorite meals and call add and add that meal to the favorites. And this is all we have to do here. This will make sure that a meal is added or removed. So now that we have this function, we have to get it to the meal details screen, because that is in the end where it should be triggered when this icon button here is pressed. The problem, of course, is that the tabs screen doesn't have direct access to the meal details screen. Instead, the tabs screen only has access to the categories and meals screen. But both these screens ultimately reach the meal details screen. I mean, inside of the meals screen, we simply do push the meal details screen. So here we could pass a pointer to this toggle meal favorite status function to the meal details screen. But in order to be able to pass a pointer to this function to the meal details screen from inside the meals screen, we first have to pass this function from the tabs screen to the meals screen. And later, as a second step, also through the categories screen to the meals screen, because that's another place where the meals screen is used. And of course, passing a pointer to a function through multiple layers of widgets like this is a bit annoying, but that's why we're going to learn about an alternative approach in the next course section. Nonetheless, this is an important pattern, which you will also see and use a lot, and therefore we're going to learn about it here. So in meal details screen, in the end, I expect to have a property which will be a function actually, so which will hold a function as a value that could be called on toggle favorite. And this here should be a function that in the end then gets a meal as an input, the meal that should be added or removed as a favorite. So therefore here in meal detail screen, we have to require this on toggle favorite parameter to then set the function that we receive on this parameter as a value for this property. And then here on the icon button, inside of this anonymous function, we can call on toggle favorite and pass our meal as a value to it. So this meal which we store in this property, because on toggle favorite will be a function that wants a meal, hence we pass this meal as an argument. Now inside of the meals screen, we now have to make sure that we pass such a function to meal details, because meal details wants this on toggle favorite parameter which wants such a function. And since we use meal details screen in the meals screen, it's this place where we have to provide this function. Of course, we don't have this function here though, we have it in the tabs screen instead, and therefore in the end, in this meals screen, we also just have to register such an extra property and require this extra parameter on toggle favorite, just so that we can forward it to meal details screen. Because there indeed we can now add on toggle favorite and set it to this on toggle favorite property that we have here. So now with that, we have to make sure that we pass this function, which we now want to get here in meals screen on this parameter, to the meals screen. So from inside the tabs screen, where we create the meals screen, we now have to set on toggle favorite, and here we finally can now set it to this toggle meals favorite status function that we create here. So with that, we're in the end creating a chain along which we pass a pointer to this function through multiple layers of widgets. Now we have to remove const here, but with that we will pass this function to the meals screen and through the meals screen in the end to the meal details screen. And there in the meal details screen, we then call it when this icon button is pressed. That's what we're doing here. Now, of course, we're also using this meals screen in the categories screen. So therefore there, we also have to accept such a function property. So we have to add it as a property and accept it as a parameter, and this must be a required parameter. Here I also must import the meal model. So this import here is required to make this meal type available in this file. And now since we get this function here and store it in this property in the categories screen, we can set on toggle favorite on the meals screen and pass this stored value in this property that's also named on toggle favorite to on toggle favorite on the meals screen. And I know this can be confusing. We're passing a function through multiple widgets here, but right now it's the only way of doing this. It's the only way of getting a function that's defined in this tabs screen to the meal details screen. As mentioned, we'll learn about a different, leaner approach in the next course section. But with that, we're almost done. Now, as a last step, we just have to go back to the tabs screen and there set a value for the on toggle favorite parameter, which we just added there, this parameter which wants this function. And finally, we therefore now can also use our toggle meal favorite status function here as a value for this parameter for the categories screen. And we have to remove const here. And with that all, we now have the logic in place to add or remove meals as favorites and to trigger that logic from inside the meal details screen. Now, of course, we have to make sure that we also output any favorites we might have set here on the favorites screen. And that's what we'll do as a next step. So now that we juggled our function around and passed it through almost all widgets that we have here, we also have to pass the favorite meals around. Though here we don't have to pass that through all our widgets. Instead, we just have to pass our favorite meals here to our meals screen if it's being displayed as the favorites screen, as it is the case here in our tabs screen if the second tab was selected. Here, instead of passing an empty list, we want to pass our favorite meals. If we do that and reload everything, if we now visit a meal and mark it as a favorite, you will see that now in the favorite screen, this meal shows up. If I then click this button again, it should be removed, but it actually is still there until I navigate away and go back here. So what's the problem here? Well, the problem simply is that in toggle meal favorite status, I am updating my favorite meals, but I'm not calling set state. And of course, we have to call set state to make sure that our update here also triggers the build method again, which then in turn will make sure that the UI is updated. So we have to wrap our favorite meals remove or favorite meals add calls into set state inside of toggle meal favorite status. And if we do that, you will see that if now I add an item as a favorite and I go to favorites and unfavorite it by clicking this icon again, it indeed is removed instantly. So that was the only problem here. But there is one other problem or potential improvement that we should make. And that's this button here. If I tap it, it never changes. So I don't really know whether I added an item as a favorite or not. It would be nice to get some feedback. Now we will make sure that the icon changes in the next course section, because right now it would be unnecessarily complex and it will be much easier in the next section once we learn about a more powerful way of managing cross-widget state like this favorite meals list state, which does affect multiple widgets. So therefore for the moment, instead of replacing this icon here, I'll do something different. In the tabs screen, where I have my favorite meals and where I know whether a meal was just added as a favorite or removed as a favorite, I want to show a little info message once we did update a meal. So therefore here I'll add a new method, show info message, where I expect to get the message of type string as an argument. And in here, I want to show a snack bar. And you learned about snack bars earlier in the course, in the expense tracker section. We can show such a snack bar through the scaffold messenger, which needs the context though, but since we're in a state object here, we have this globally available context, so that's quite convenient. And then here, I first of all want to clear all existing snack bars if we're already showing some. And then thereafter, we can show a new snack bar by calling show snack bar like this. And to show snack bar, we pass a snack bar with any content of our choice, where content is a widget. And here for me, it will just be a text widget where the text is the message I'm getting here. Now we could also set a duration then, but the default duration is actually 4 seconds, which works for me here. So I'm just setting the content. And now we can call show info message from inside here. So if we just removed a meal from the favorite meals list here, I'll call show info message with a text of meal is no longer a favorite. And alternatively, if we added a meal to the favorite meals, I'll send a message of marked as a favorite. Something like this. Now with that, we get at least a little bit of feedback if we select an item and mark it as a favorite, because now we get this snack bar at the bottom. And we also get that if we mark this item as no favorite. So that's quite good, quite convenient. We got some feedback here, which is good. Again, we'll work on the icon in the next course section. But with that, this favorite feature is working. We can add and remove favorites as expected. And now with that, we can move on to the last part of this section and make sure that we add a side drawer that allows us to switch to a filters page where we can set some filters that will influence which meals do show up if we do select a category here. So now that we have our tab-based navigation working and we can mark items as favorites and see them under the favorites tab, it's time to add this side drawer, which I mentioned earlier. A side drawer which we can open up to go to a filters screen on which we can set various filters which will then impact which meals we see when we select a category. And just like tabs, which we added with help of bottom navigation bar on Scaffold, such a side drawer is an absolutely common and standard feature and therefore very easy to add with Flutter. Indeed, it's again the Scaffold widget that allows us to add a drawer to this screen, because that's also important to understand. Side drawers are added on a per screen basis. If you want to have a button that opens the side drawer on a specific screen in the app bar, you have to add it to the scaffold of that screen. So here, if I want to have a side drawer on both tabs, I have to add the side drawer to the tabs screen scaffold. And that's exactly where I'm at in my code. So there on Scaffold, we can then add the drawer parameter. And as you can already see, you also got a couple of other drawer related parameters that allow you to basically configure the behavior of the drawer and listen to certain events. But here I'll simply add the drawer parameter, and this wants a widget in the end. A widget that will be presented as the drawer. Now for that, Flutter has the built-in drawer widget, which is simply a widget that's optimized for being shown as a side drawer. But since I'm about to add a lot of content to that drawer, I'll actually create a brand new widget, my own custom widget, in the widgets folder therefore, because this will now not act as a screen, but as the side drawer instead. And I'll name it main_drawer.dart. Of course, as always, all these names are up to you, but in this file, I'll then add a new class, main_drawer, and this class will extend stateless widget, because even though this drawer will then provide buttons that take us to different screens, will again perform this navigation with help of the navigator object and not by setting some state. Hence, the drawer widget can be stateless. Now in this drawer class, we therefore as always add the build method and also a constructor, main_drawer, where at the moment I only accept and forward the key, as we always do. And now here in the build method, I will return that built-in drawer widget. Now this drawer widget gives you a bunch of configuration options, like for example setting the background color of the drawer, or the color of the background shadow that will be displayed below the drawer, or with elevation you can basically define how much drop shadow you want to have behind the drawer. But here I'll simply set the child, which defines the content inside of the drawer. And as I mentioned, the drawer widget is already a widget that's optimized to be presented as a drawer, so it will, for example, automatically make sure that it takes the entire screen height, and so on. So here, as a child, I'll then add a column because I want to have multiple items above each other in that drawer. And for that, of course, we set our children here in this column, as we always do. And then the different children that I do want to set are basically a header at the top of the drawer, and then below that a couple of clickable or tappable items that take us to different screens. Now for the header, we can use the built-in drawer header widget, which is another widget optimized for its role. In this case, optimized for being used inside of a drawer to show some header, as you might guess, at the top of the drawer. Now, drawer header can be configured in different ways and accepts different parameters. And I will, for example, also soon add a decoration to it to style it, basically. And also add some padding, which is supported here with the padding parameter. And I'll start with that and give it a padding of 20 in all directions, like this. And then in addition to this, I'll also re-add decoration and set this to a box decoration object, as we did many times before for other widgets as well in this course. And I'm doing this so that I can add a gradient here. And I guess that was the most common scenario where I used box decoration thus far in the course for adding gradients to widgets, and I'm doing the same here. Now the gradient is created as we always do it with the linear gradient class here provided by Flutter. And then we can set our colors and then also begin and end. Now for the colors, I'll use some colors from my theme with theme of context using this context object, which we get automatically in the build method. And then here I'll reach out to my color scheme and use the primary container as a starting color. And for the end color, I'll also use color scheme primary container, so I'll copy that, but then I'll add some opacity to it to have a slight gradient between the same colors, but where one color has some transparency. And then I'll begin with that gradient in the top left corner with alignment top left, and I'll end in the bottom right corner like this. And with that, I got some styling added to the drawer header. Of course, it also needs a child though, which simply defines the main content inside of this header. And for that here, I'll add a row as a child because I want to have multiple items next to each other inside of that drawer header. And the items I do want to have next to each other here are an icon and then a sized box to add some spacing and then some text. Now for the spacing, I'll use a width of 18 pixels. For the icon, I chose the fast food, which is a built-in icon, of course, that looks like this. And I'll actually change the size of this icon to make it quite big by assigning 48 pixels as a size. And I'll also change the color of this icon, and again use my theme for that to reach out to theme of context color scheme, and then there choose the primary color. Now for the text, I'll simply give it a text of cooking up, like this. And also set a style here where I will again use the theme, and then of course the text theme property on the theme, and there for the text theme object, to access the title large styling, but I want to adjust it a little bit, hence I'll add an exclamation mark to tell Dart that I know that title large will be defined in this theme, to then call copy with and override some settings, specifically the color where I will again use the theme, and of course as always the color scheme thereafter, and then the primary color. So that's the content of this row, which in turn is the content of the header. And with that, before we add anything else, I want to see whether this drawer is displayed correctly and whether this header looks good by going back to tab start. And here for this drawer parameter on scaffold, I will add my main drawer widget here. And we can add const in front of this. Of course, we must make sure that main drawer Dart is imported in this tab start file. But with this import added and the drawer set on the scaffold as we're doing it here, we can save everything, make sure that the app is up and running. And if you go back to your app, you should now see this menu icon here in the top left corner, on Android at least. And if you tap it, you open up this drawer where you see this header that we added, which looks the way I want it to look. And if we tap on the background or we slide this in, we can close this drawer. So that works as it should, and that's awesome. And we can also access this from the favorites page because that's still part of the tabs page, though we cannot access it if we dive into a category. For example, there we have this back button as we want it. So this all works as intended. And therefore now the next step is to add some items to that drawer, some tappable items that take us to different screens. So in order to go to different screens, I'll go back to the main drawer here, and there below this drawer header in the children list of this column here, so here after drawer header, right before I close this list of children for the column, I will add more content. Specifically, I'll add the links to the different screens I want to support in this app. And for that, I'll use another built-in widget, which is not exclusive to the drawer, but which you can use in any list you might be outputting, and that would be the list tile widget. I haven't really used this widget a lot thus far, but it can be a great widget for outputting list content since it's simply optimized for bundling different pieces of information together in a single row. Here I'll use Flutter's list tile widget to output my drawer links. For that, the list tile widget accepts multiple parameters that offer you rich configuration options. And you can, for example, set a title here to add the main content of this list tile in the end. Any widget is accepted here. And here I'll simply go for the text widget to then output my different, drawer link texts. For example, meals for the first list item, so that this would be the list item that takes us back to this tabs screen, for example. So that's the title I'm setting here. And I'll add a style here, again, by reaching out to my theme. So from that theme, I'm going to grab some styling. Here, I'll not use title large, but instead title small, and see how that looks like. And then I'll set my color here, my text color, to on background. And I'll also override the font size and set it to 24. So with that, I set this text on this first list tile. That's not all I want to set though. I also want to add an icon in front of this text essentially. And for that, we could set title to a row, where we then manually add an icon next to a text, but the list tile actually also gives us a leading parameter, which allows us to set a widget that will be presented at the beginning of this row of this list item, so that this title comes after the leading widget. As I mentioned, list tile simply is a built-in widget that's optimized for outputting items in a list, so inside of a row that's part of a list. And leading allows us to add some widget that will be displayed at the start of that row. And here the leading widget I want to output is an icon. And for this meals item here, for this meals link, I'll use the built-in restaurant icon. I'll then also set the size of this icon to 26 and change the color of the icon and set that to theme of context, color scheme, on background, so the same color I used for my text down there. Now with that, we would be displaying one link in our drawer, but of course it wouldn't be useful if it wouldn't be tappable. And therefore, of course, besides adding leading and title, I'll add one last very important parameter to list tile, and that's the onTap parameter, which wants a function as a value. And later, we'll make sure that when this function gets triggered, we navigate to a different screen. So that's the first step. The next step is to copy this list tile and add a second one. But in this one here, we'll go to the filters screen, which we have yet to add. And I'll use a different icon here, the settings icon to be precise. But besides that, it's the same configuration as before. And therefore, of course, we could outsource this into a separate reusable widget, but here I'll just go with copy and pasting. And with that, I added the 2 items I want to have in that drawer. And if you now save that, you should be able to open that drawer and see these 2 items. And they are tappable, but of course at the moment nothing happens when I tap them because I haven't added any logic to those tap functions here. But that is what we'll do next. So let's now make sure that if we tap those drawer items, we actually navigate to a different screen. Now for that, we could go to these anonymous functions that are set as values on tap, and indeed use navigator of context to then push a different screen on top of the screen stack right from inside this drawer. And this wouldn't necessarily be wrong, but it would cause one problem here. In this app here, we will in the end need to manage the active filters that have been chosen on that to be added filters screen. We will have to manage those inside of the tabs Dart file because it's inside of this tabs screen widget here where we in the end load the categories screen. And the categories screen then in turn will load the meals screen. If you remember, inside of categories Dart, we push the meals screen, and the meals screen will need to know which meals should be displayed. And therefore, of course, in the future, we'll have to make sure that we pass this information about which filters have been selected to this meals screen, and therefore in the end also to this categories screen, and therefore we will need that information inside of this tabs screen, because that is our main data management widget in the end, because it's this tabs screen widget that loads all the other meal related screens that need that meals and filters information. And for that reason, I'll not do the navigation from inside my main drawer widget, but instead in this main drawer widget, I'll add a new property, a function, which will need some string identifier as a parameter. And you'll see what this parameter is all about in just a second. And I'll name it onSelectScreen or anything like this. And of course, then I'll make sure that this parameter of the same name is required and bound to this property. Now, the idea is that this function, which we store in this property, can be called from inside onTap here for these 2 list items. And here for this first list item, where we want to go to the meals screen, I'll pass an identifier of meals. And on this second list tile, where we want to go to the filters screen, I'll call onSelectScreen and pass filters as a value. That's the idea behind this string identifier. And the reason for adding such a string identifier here is to make sure that in tabs Dart we can define this function, which we expect as a value here in main drawer, and which we then bind to this onSelectScreen. And in tabs Dart, we then get this identifier to decide which screen should actually be loaded. And then we can manage and pass the data that might be required by that screen accordingly. So therefore here in tabs Dart, I'll add a new function, which I'll name setScreen. And here I'll expect to get this string identifier. And it's this setScreen function that will be passed as a value to main drawer under this onSelectScreen parameter, which we added. And now we have to remove const here. So with that, the main drawer can in the end communicate with the tabs screen, and it will be this setScreen function, or method to be precise, that will be executed if one of these list tiles will be pressed. And we will simply get a different identifier value inside of this setScreen function depending on which drawer item was pressed. And here we can then check, for example, if identifier is equal to filters to then load the filters screen, which we have yet to add, and else we know it must be meals, and in this case we can load the tabs screen. Now for this else case here, so if you want to go to the tabs screen in the end, it's of course important to keep in mind that we already are on this tabs screen here. So if we open the drawer from this tabs screen and we then selected meals in that drawer, we effectively just want to close the drawer because we already are on that meals screen or in that meals area of the app already. And therefore, if we just want to close the drawer, we can do this through the navigator object and close it just as we closed modals or dialogues before in this course. We can simply use pop like this. The context is available here because we're in a state class, in a class based on state here. So that's how we can close the drawer if we are on the meals screen, on the tabs screen in the end, and we want to go back to the meals area. And therefore, if you save this and force a reload, you will see that if I open this and I click meals, I simply close the drawer. So this works as it should. So now let's make sure that we can also go to the filters screen. And for that, we first of all have to add such a filters screen. Now we need a new screen, the filters screen, and therefore in this screens folder, I'll add filters.dart, which, as you might guess, will hold my filters screen widget. And this actually must be a stateful widget here, because we'll need to manage some internal user input state in this widget, since we will present multiple switches to the user that can be used by the user to set various filters. So here we have the stateful widget, and of course, as always, we have the create state method here, and we also have filters screen as a constructor here, where I forward my key like this. And then I'll add the underscore filters screen state class where I extend state for filters screen like that, like we did before. And also use that here as a value for this generic type. And then here we add the build method. Now here in create state, we then return a new instance of our filters screen state class. And in the build method down here, we then return a scaffold because this is a brand new screen and therefore it gets its own scaffold so that we, for example, can set an app bar for that screen. But also so that we soon can add the drawer because this screen will also need access to the drawer so that we can leave this screen. But I'll get back to this in a second. So here we have the app bar and I'll add a title here on this app bar, which I'll set to a constant text widget where I simply say your filters. This sounds like a fitting title. And then of course we also need a body here, so the main content of the filters screen. And here I'll go for a column because I want to display multiple filter switches in the end. Switches that will be shown below each other that can be used to turn these different filters on or off. So therefore here I add children, and now every switch will be a switch list tile, which is a convenience widget provided by Flutter that's optimized for being presented in a list, because this will then display one single row in that list, but in a list full of switches, where you can set a label for every switch, but you'll then also have that switch widget that can be tapped by the user to turn something on or off. So that's a very convenient widget for rendering, for example, setting lists, as we're doing it here in the end. And switch list tile wants a value, which is a boolean, so which is simply true or false, controlling whether the switch is currently turned on or off. And then an onChanged parameter that in the end wants a function that receives a boolean, which will be triggered whenever such a switch is pressed. Now I will add both in a second, but before I do that, I'll add some other parameters which I also want to set on the switch list tile. For example, the title. The title parameter can be used to add a label that will be shown next to the switch. And here I want to display some text with help of the text widget. And the text I do want to display here for my first switch is gluten-free, because this first switch will be about setting this filter. I then also want to apply some styling to this text here. And for this, I'll use my theme, the text theme, and their title large. and again copy this with some extra settings which I'll change, and the setting I will change here will be the color, which I also take from my theme, but where I then want to use the on background color from my color scheme, like this. Now, in addition to setting this title, I'll also set a subtitle, which, as the name kind of suggests, is a parameter we can set on switch list tile to render some typically smaller text below the main title, the main label of the switch, so to say. And in this case, I'll use subtitle to render some extra explanation. And for my first switch here, where I toggle the gluten-free filter, I'll say only include gluten-free meals. This is simply some extra explanation which I want to add here, and I will also adjust the style of this text here, and hence I'll copy the style from my title. But here I don't want to use title large as a starting point, but instead label medium, which simply displays smaller text, but I'll also set the color to on background here. Thereafter, I'll also set the active color parameter, which allows us to control which color will be used for rendering this switch if it's activated, if it is turned on, so to say. And here I'll also use a color from my theme, and I'll use the tertiary color here. Last but not least, I'll set the content padding parameter to control how much padding will be used inside of this list tile in the end. And here I'll set this to edge insets only, to only target specific directions. And I'll set a padding to the left of 34 and to the right of 22. And of course, you can tweak and fine-tune these values as needed. So that's the base configuration for one row in my list of settings, which I will in the end have. And now, of course, we have to come back to the value and on changed. Now, the value will be some state that I manage here, because of course the value should be changeable, and if it is changed, it should be reflected back on the user interface. So here I'll add a variable to the filters screen state, which I'll call underscore gluten-free filter set. And initially this could be false, so that initially the filter is not set, though soon we're going to load the data that has been set by the user in the past. But at the moment, I'll always initialize this to false, and then use this as a value down there. And then for onChanged, I'll add an anonymous function. We could also add a separate method to this state class, of course, but here I'll go for an anonymous function where I get the new value, or simply the answer to the question whether this is checked or not. This parameter name is up to you because it's your function, but it will always be a Boolean because this function will be called by Flutter for you, and Flutter will pass a Boolean value to that function if you want it or not. But now here I can use this isChecked information to update gluten-free filter set. And for that, of course, we have to call setState because the UI should reflect that change. And then I'll set gluten-free filter set equal to isChecked, so to this parameter value here. And with that, we should have a first list item. Now, before we add all the other list items, I'll save this and make sure that we can actually see this. And of course, to see this, we have to make sure that this filters screen actually gets loaded. For that, we can go to Tabs Dart, and here in Set Screen, if the identifier is set to filters, I do want to go to this filters screen. Now, of course, we can do this as we did it in the past by using Navigator of Context, and then push a new material page route, which has this builder function where we get the context and then return the screen widget that should be loaded. In this case, the filters screen widget, which at the moment can be set to a const value. Now, of course, as you know, in order to use filters screen here, you also must make sure that you're importing filters Dart into this tabs Dart file. With that done, you can load it like this, and if we would add this code and save everything and restart, you will see that now if you tap filters, indeed you're taken to the filters screen. Now here on this filters screen, we then have this list item. And here we can toggle this setting as expected. And we do have this back button. And if we press this, we're taken back. But of course here, the drawer is still open, which is rather strange. Now, of course, it is still open because we never closed it. We just navigated to a different screen. Now what we can do is we can go to the tabs screen, and before we navigate to the filters screen, we can call this code here to close our drawer. So to pop the drawer before we then navigate away. And now, since we actually have the same kind of code in both branches, we can simplify this code and always execute it outside of the if statement right at the start of set screen, since we always want to close that drawer. That never changes. It does not depend on this condition. And we can therefore also get rid of this else branch here, so that we always close the drawer, but if the identifier is filters, we then also navigate to a different screen. With that logic added, if you open the drawer and go to filters, you reach that screen, but if you go back, you see the drawer is not open. And that is a pretty nice behavior, I'd say. Now you could also want an alternative behavior where you also have a drawer inside of your filters screen. For that, in Filters Dart, we could go to scaffold and of course also add our main drawer here. We then also, of course, need to add a setScreen method to this class here and pass it to main drawer so that we can react to an item being tapped. So we have to set this onSelectScreen method here where we accept this identifier, and we can do this with an anonymous function as I'm doing it here, or add a method to this class. Here I'll just go with an anonymous function, and then here we could basically do the same as before. Always call navigator of context pop, but if the identifier is equal to meals in this case, since we're on the filters screen, we want to go back to the tabs screen. And this could be achieved by using navigator of context, push material page route, and here we got the context, and I want to go to the tabs screen like this. Now, of course, as you know, for this to work, you also must make sure that you added the appropriate import for tabs screen so that you are importing tab start. And if you do that, you will see that now, if you go to this filter screen, the back button is gone and it was indeed replaced by the drawer button here. And here you can then go to meals, for example. So that's now simply a different way of navigating around. Now what you'll notice though is that if you use the physical back button on your device, which on the simulator here, on the Android emulator, can be emulated here with help of that toolbar on the right, you indeed can go back through all these navigation actions that you performed. Because of course you did still push these screens on this stack of screens, you just don't have this back button here in your app because you're setting a drawer. And hence this drawer icon and this drawer button is used instead of the back button. But technically there still is this stack of screens going on. And that might be the behavior you want, being able to go back with help of the back button, but you also might want to replace the current screen with the new screen if you're using the drawer. So that if you are on the tabs screen and you go to the filters screen, you actually don't push this screen onto the stack of screens, but instead you replace the currently active screen with the filters screen so that the back button would not work and would not take you back. And since this is also a pattern you should know, I'm also going to show you how this could be implemented. Because it's really straightforward to do. You just replace push, for example here in the tabs screen file, with push replacement. And the rest stays as it is. But this will now make sure that filters screen is not pushed as a new screen onto the stack of screens, but that instead the currently active screen, in this case tabs screen, will be replaced with the filters screen. And therefore the back button wouldn't work because there is nowhere to go back to. And you can do the same in the filters screen. There, when you navigate to the tabs screen, you could use push replacement instead of push. If you make those changes and you restart your app, you will see that the drawer still works as before, but if I go to the filters screen and I then press the back button, I actually close the app because there was no screen to go back to, and then the default behavior indeed is to close the app. So that's simply an alternative navigation pattern which you should also be aware of, which is why I'm showing it to you. Now here I actually don't want to use that pattern though. Indeed, I don't even want to have this drawer button on my filters screen, though you could absolutely use it, but here I don't want to have it. I'll comment it out so that you still see how that code could look like. But I'll comment it out because I'm happy with having a back button on the filters screen to go back to the tabs screen. But of course, this also means not only that these imports aren't needed anymore, but that we also have to make sure that the back button on the filters screen can actually work by ensuring that we don't use push replacement here on the tabs screen, but just push, so that we do push the filters screen on top of this stack of screens, so that there we will get this back button, which then will actually work. And with all of that, if we save this, we should have the same behavior as before, where we can go to filters, change something, go back, and this all works. Of course, right now our filter state isn't saved and we only have one item here on the filters screen, but these are the things we're now going to work on next. So on this filters screen, we have one switch list tile for the gluten-free filter, but of course that's not enough. I have 3 other settings which I also want to be able to set from there. And therefore I will copy this, and again we could outsource it into a separate widget instead, but to save some time I'll just copy it here. And my second switch list tile here will be all about controlling the lactose-free filter. So I'll adjust the title here accordingly. Of course, the styling is the same, so it's really only the text that changes. Also for the subtitle. And we'll need to manage some new state. Hence, I'll add a new variable here, the lactose-free filter set variable. And we can also already add variables for the other filters that can be set. For example, the vegetarian filter and the vegan filter. And then we can go down there again to the switch list tiles, and for the lactose-free one, I'll change the value to use this new underscore lactose-free filter set variable, and also update that variable if the list tile is tapped or changed, to be precise. And then I'll copy this switch list tile again, also add a comma here, but copy it again, and now add the vegetarian filter here. Only include vegetarian meals. And then last but not least, add the vegan filter where I only add vegan meals. And I also need to update those values and state updating functions. So for the vegetarian list item here, I refer to the vegetarian filter set and update that variable here. And for vegan, it's the vegan filter set, which is also updated here. Now with that, we should actually see all these options here. If I go to filters, yes, and all these options work independent from each other, which is of course quite nice. Now we just need to make sure that these settings here are also saved when we navigate back, and then also do affect what we see here when we do choose a category. For example, I don't want to see a hamburger if I actually selected vegetarian or vegan. So that's what we'll work on next. So we got this filters screen where we can set our filters. Now we want to make sure that if this back button is pressed, or also of course if the physical back button on the device might be pressed, we pass those selected filters back to the tabs screen, where we then use them to, in the end, narrow down which meals will be shown if we, for example, select the hamburgers category. Now, therefore, we must find a way of passing those variable values that are managed here in Filter Start, in the filters screen state, back to the tabs screen. And for that, of course, we need to find a way of knowing when the user tapped the back button, the physical one or the one in the top left corner. And this is another common requirement, and therefore Flutter helps you with that. It gives you a special widget, which you can use here in your scaffold to wrap it around your body. And therefore that's what I'll do. I'll wrap a widget around my column here. And the widget I will wrap around it is the will pop scope widget. Will pop scope is a utility widget that, as you can see, essentially wraps the entire content of this screen here. And will pop scope allows you, and actually wants you, to set a on will pop parameter. And on will pop actually wants a function that returns a future. And you might recall I mentioned futures earlier. Futures are these objects which eventually resolve to other values, values which are not there yet. So a function that returns such a future, and that function will be invoked by Flutter whenever the user tries to leave this screen. So here we can pass a function, and this function receives no arguments. But in this function here, we can now manually call navigator of context pop. And the advantage of doing so is that pop actually allows us to pass some data along with it. Some data which will then be available in the place where we navigated to this screen, so to the filters screen. Well, and that place is our tabs screen. There, it's in this set screen method where we in the end navigate to the filters screen. So therefore it will be here where we will get access to the data returned with help of pop from inside this filters screen. Now here you can return any kind of data. And what I will return here will be a map where I want to have different keys for my different filters, and then true or false depending on whether that filter has been set or not. Now for that, to standardize those keys, I'll actually add an enum in this filter start file at the very top of the file, which I'll name filter. And here I'll add some unique identifiers for all these filters that we can set. So here I'll go for gluten-free, lactose-free, vegetarian, and vegan. So that we have these clearly defined keys, and these should be my keys in this map which I want to return. So my map here, which I'm returning in pop, will have those different enum values as keys. So filter.glutenfree as a key, for example. And then as a value, separated by a colon, as you learned, the currently stored value for that filter, which for this gluten-free filter would be stored in this underscore gluten-free filter set variable. So that's the value I want to set here. And I'll now repeat this for all my other filters here. So for lactose-free, for vegetarian, and for vegan, like this. And therefore, this map here will be in the end what will be returned by this filters screen when it's popped, so when the back button is pressed. And we will then be able to access this data, this map here, from inside the tabs screen, because that is where we navigated to this filters screen. Now we're not entirely done yet, though. Instead here, in this will pop scope widget, in this function here, we have to return true or false to in the end confirm whether we want to navigate back or not. And since we are navigating back manually here, we should indeed return false so that we're not popping twice. If you would not be popping manually here, but doing anything else, like saving data to some database, it would make sense to return true instead. If you wanted to allow the user to leave the screen, here we'll return false, since we already have our leave screen logic here, and we don't want to pop twice, because that would essentially mean that we would probably close our app. So here we return false, but here we pop manually, essentially leaving the screen with this data being passed back. And now we just have to keep in mind that onWillPop actually wants a function that returns a future, which eventually yields a boolean, instead of getting a boolean right away. And therefore, to make sure that this is the case, we should add the async keyword here between this empty parameter list and the opening curly brace. Because by adding async here, you can not only use the await keyword as you learned before in this course, but instead you will also automatically wrap the value returned here into such a future. So that's a convenient way of creating a future that will be returned by your function. So by adding async here, this function will return a future that will then eventually resolve to this false value. And with that, we have control over this going back process, and we pop manually with our data. Now we just need to read that data in that place where we navigated to the filters screen. Now to read that data that might be passed back by pop, we can go to this place where we called push. And here it's interesting to see that this push method, which we're calling, actually returns a value. It returns a future. Thus far in this course, we haven't used that value, but that's now going to change. Because we'll get a future here, which will in the end resolve to the data returned by the screen where we navigate to, so to this map in this case. We'll get a future that contains this map. And it will be a future instead of getting this map right away, because of course when we push this screen onto this stack of screen, we don't immediately get back that data. Instead, the user may interact with that screen and may press the back button after 10 seconds, 10 minutes, or 10 hours. And that's why it's a future. We don't have the return value available immediately, but at some point in the future, once the user did navigate back. So that's why we get a future here. And to use this future in a convenient way, we can add async here between parameter list and curly brace, so that here we can use await, so that in the end then we got the result stored in this result variable. But this will only be set once the user did navigate back, so once this future did resolve. We wait for that to happen here with help of the await keyword, so to say. Therefore, in the next line thereafter, result will be available and will be set to the returned data. Now, right now, the type of that data is dynamic because here in this file, we don't actually know which data will be returned by this filters screen. Now, since we're the developer of this app, we actually do know, and we do know that it will be of type map, where the keys will be of this filter type and the values will be Boolean. And therefore, we can pass this extra knowledge here to Dart as well by adding angle brackets after push, because push is a so-called generic method. You can tell by these angle brackets which you see here, just as list was a generic type. With list, you could, for example, define which kind of values would be stored in a list. Here, with the angle brackets after this generic push method, you can define which kind of value will be returned by push. Because you can see here that the generic type you define after push, this type T as it's named here, will be the type of data the future will resolve to in the end. So here we can tell Dart that it will be a map which itself is a generic type, where our keys will be of type filter. And this is the filter enum defined in filters Dart at the top of this screen. It's available in tab start because we are importing filter start here. So that's the key type of this map. The value type will be bool because we'll have a bunch of Boolean values in this map. With that, indeed, Dart does now know that this result eventually will be such a map that has filter keys and Boolean values. And therefore, for the moment, I'll just print this result to see whether this works as expected. Later, we'll of course do more meaningful things with it. But for the moment, I'll print it, save everything and reload this app. And now if we go to filters and set, let's say, gluten-free and vegan, and I go back, this works. But if I now open my debug console, I also have this log message here where I indeed see that I got a map, you can tell by these curly braces, with my different filter keys. And then true for gluten-free and true for vegan. A bit hard to read, it's cut off, but it's true here. And false for lactose-free and vegetarian, which is exactly what I set. So passing this data from the filters screen to the tabs screen works. Now we just have to make sure that we also use that data here in the tabs screen. So now that we're getting our filters here, we have to manage them in the tab screen, and we then have to make sure that we pass the updated list of available meals based on the filters that were set to the categories screen. Because in that categories screen, we then need to pass the filtered meals down to the meals screen. And in the future, we'll have to filter not just based on the selected category, but also on the filters that have been set. So for that, back here in Tab Start, I'll get rid of this line where we printed our selected filters, and I will instead add a new variable to this tabs screen state where I want to store the selected filters. This new variable will be of type map, and it will be a map where the keys are of this filter type and the values are booleans. And we can name this variable selected filters like this. And initially, this should be a map where I also set all these filters, so gluten-free and so on. But initially, I'll set this to false, and it will then be updated once some filters have been set. So we have gluten-free, lactose-free, which initially is false, so the filter is not enabled. That is what false means. Vegetarian is set to false, and also vegan is set to false. That's the initial value here. And this value should now be updated whenever we receive new information from the filters screen. So therefore here in set screen where we get this result, and this result is just such a map of filters as you learned, we want to set the selected filters equal to the selected result. Now, storing the filters like this is not enough, because we also should make sure that the build method is executed again, so that the updated filters or an updated list of available meals is passed to the categories screen. By the way, not to the meals screen, because I don't want to filter the meals that are visible on that screen. Of course, you could filter there as well, but my logic is that favorites should always be visible no matter which filters were selected. That's why I only worry about the categories screen. Therefore, here in set screen, I'll call set state and set my filters like this. And here we now also have the problem that result could be null, and null is not an allowed value here for selected filters. And therefore here I'll use a special operator, the double question mark operator, which is an operator built into Dart, which simply checks whether the value in front of it is null, and if it is null, the fallback value defined after the double question marks will be used. So this operator allows you to set up a conditional fallback value in case this value should be null. And the fallback value I want to use here, if result should be null, is essentially this map of initial filters again. And therefore, to avoid some code duplication, we can actually also add a new variable, a new global variable, or even a constant, which we're never going to change internally, that could be named k initial filters, k at the beginning, to kind of follow this Flutter convention of naming global variables with a k at the beginning. Technically, it's not required. But this would be my initial filters, and that's now what I use here for initializing selected filters, but what we can also use as a fallback value down there after the double question mark. And with that, we're setting the selected filters whenever we come back from the filters screen. And now we can use these selected filters to update the meals we're showing once we picked a category on the categories screen. So now when it comes to passing the filter data to the categories screen, we have two main options. We can either pass a list of available meals, which then can be picked up and used from inside this categories screen, or we pass the filters and add the logic for filtering out certain meals to this categories screen. And I'll go for the former option, where I actually create an already filtered list of available meals, which can then filter a bit more for a fitting category inside of the categories screen. So therefore here I'll add a new final variable, available meals, which in the end are my dummy meals, which are coming from the dummy data Dart file, which therefore also must be imported into this tabs Dart file. And now the available meals here should be the dummy meals, filtered such that the selected filters here are taken into account. Now for that we can use the where method, as you learned, which exists on all list objects and which allows us to filter a list. We pass this function to where, which you saw before, which is executed on every list item, so on every meal, and we receive that value inside of this function. And then in here we want to return true if the meal should be kept and false otherwise if it should be dropped. But of course this should now be derived dynamically, and to derive it dynamically I'll add a if check in there in this anonymous function that's passed to where I take a look at my selected filters and I take a look at the gluten-free filter, for example, by accessing that value by its key, and that will be true or false, true if the filter is set, false otherwise. So with this code here, I'm essentially checking whether the gluten-free filter is set, and I combine this with another condition, with this double ampersand operator, which I introduced before in the course, to check that if this filter is set, I want to take a look if this meal maybe is not gluten-free. Now the meal has a is gluten-free flag, a property called is gluten-free, which is true or false. And I want to check if that is not true by adding an exclamation mark in front of this. That's how you can check for the opposite of a certain value in Dart. So is gluten-free is true or false, and I want to check whether it is not true. And I do this by adding an exclamation mark here. So if I only want to show meals that are gluten-free, and this meal here is not gluten-free, then I don't want to include it, so then I'll return false. That's what I'm doing here. And here I also need to add an exclamation mark after this code, which does now not check for the opposite. This only happens if you add it in front of a value. If you add it after a value, it's simply a Dart feature which you saw before, which tells Dart that this value in front of the exclamation mark will never be null. And I know that this will never be null because selected filters will always be set to at least this starting map, which has all these keys. So with that, I'm checking whether this filter is set and whether our meal maybe does not satisfy this filter, in which case I return false and exclude this meal. And now this logic can be repeated for all filters. So I can also check for the lactose-free filter, if this is set and active. And if it is, I want to exclude meals that are not lactose-free. And then I repeat this again for vegetarian. And I want to exclude meals that are not vegetarian. And last but not least, of course, also for vegan. Exclude meals that are not vegan. That is the logic here. And with that, available meals will be a list that only includes meals that meet our filter conditions. Or to be precise, it will be an iterable, and therefore here I will call toList to make sure that I actually return a list and not an iterable. And I also need to add one more return statement here in this anonymous function that's passed to where I return true. Otherwise, I just have a bunch of checks that potentially return false, but I never return true for the meals that I actually want to keep. And of course, I definitely do want to keep all meals that don't make it into these if blocks, so that meet all the filters set, and that's why return true is needed here at the end. And with that, we're getting this available meals list, and it's now this list that should be passed to the categories screen. So there we can add a new property, a list which is full of meals. And it could be named available meals. Sounds like a fitting name. We of course also add it here as a required parameter, like this. And now it's the available meals instead of all the dummy meals that we'll use as a starting point for finding meals that fit the category that was selected. So here we now use available meals instead of dummy meals. With that added, with this parameter added to the categories screen, we can go back to the tabs screen, and there, when we create the categories screen, we can set the available meals to the available meals we are deriving here. So to the value stored in this variable, like this. And now with that, last but not least, we should be able to filter our meals as expected. If I now go to filters and I, for example, only show vegetarian meals, so I exclude all meals that are not vegetarian, I don't see anything if I go to hamburgers. And under quick and easy, I also have less meals available. So this now indeed does work the way it should work. And if I set more filters, like gluten-free and vegan, and also lactose-free, I of course see even less meals, because now I narrowed this down even more. And that of course therefore works as it should. The only thing that's not working is that if I go back to the filters screen, all filters are reset back to nothing. So therefore thereafter I also see all meals again. And that's of course not how it should work. Instead, the filters I set here should be saved so that they are also shown again if I go back to the filters screen. Now to save those filters and to not reset them if I go back to the filters screen, we have to make sure that from the tabs screen, we pass the currently active filters to the filters screen so that there, instead of initializing all the filters as false, as we're currently doing it, we're actually initializing those filters to the values that have been set before. And to do that, we can go to the filters screen here and add a new property and parameter to our filters screen widget. The property can be named current filters, and the type of value stored in this property should be this map of filters, like this. And of course then I expect to get this as a parameter. Now that we do get this, we can use the current filters to initialize our filter state variables here. Now since we're technically in a different class here, we're not in the widget class but in the state class, we can't access current filters like this here. Instead, you learned earlier that there is this special widget property which you can use to access the properties and methods of the widget class, like current filters. The only problem with that is that the widget property is not available here where you're initializing your class variables. Instead, it's only available inside of the methods of this class. Therefore, what I'll do as a workaround is I'll initialize all those values as false again, but I will add this init state method, which you also saw earlier in the course already. And here, after calling super init state, I'll overwrite those initial values here, like gluten-free filter set, with the values I got here in my widget, so with the current filters. Because here in init state, we can use this special widget property to get access to the current filters. And then here we can access filter gluten-free, for example, to get the initial value for this variable. We just have to add an exclamation mark here to tell Dart that this will not be null, which we know it won't because this is a required parameter. So with that, we're initializing it like this. And here we also don't need to call setState because init state will run before the build method executes anyways. So these here are the values that will be available once the build method executes without us calling setState here. And I'll then repeat this for all these state variables. Here I'm accessing current filters, filter lactose free with an exclamation mark. Then we repeat this for vegetarian filter set and access filter vegetarian. And last but not least, here we have vegan filter set and access filter.vegan. So with that, we now initialize these state variables to the actual values that have been saved as state before. At least if we make sure that the current filters are passed to the filters screen when it's being activated. And therefore we have to go to the place where we are activating this screen, so where we are pushing this screen, which is the tab start file. And there in the place where we are pushing this screen, here we now have to set this newly added current filters parameter and set it to our selected filters map. And now we have to remove const here because now a dynamic value is passed to filters screen. So with that, we now should preserve those filters that have been selected. And hence, if we reload this and I set some filters here, those of course still affect those meal lists as before. But if I go back to filters, you now see that this was saved, and therefore of course it also still applies if I go back to my meals. If I then go back and clear those filters or choose different filters, that of course will also be taken into account, and now I see more meals again. And that's now the finished meals app. And that's it for this course section. We built this meals app where we can dive into meals, mark them as favorites, and then also see them here under this favorites tab. We can go to filters and there set different filters which actually won't affect our favorites, but which will affect what we see once we pick a category. And whilst building this app, you learned a lot about navigation in multi-screen Flutter apps. You learned that you can remove screens with pop, but even more importantly, you learned that you can add new screens and navigate to a new screen with the navigator object and then the push method, or also with the push replacement method, which could be used to replace the currently active screen with a new screen. Because you also learned that in the end, this whole navigation concept is all about having this stack of screens where you push new screens onto this stack or pop them off that screen, and it's the topmost screen that's visible to the user. That's how navigation works in Flutter apps. And in this course section here, you did not just learn how you can go forward and backwards and how you can dive deeper and deeper into screens, but you also learned how you can add tabs with the bottom navigation bar, how you can store which tab is currently selected to make sure that the correct tab is highlighted, and how you can move between different pages or screens based on which tab was selected. And you also learned how you can add a side drawer. So a drawer like this, which allows you to move to different app areas, so to different screens through that drawer-based navigation. You learned how that works, how you can build your own side drawer and configure it exactly as needed, and how you can also go back and even make sure that you got full control over this process of going back, not just when using a drawer, but anywhere in your app. Here we just used it in the context of a screen which we reached through a drawer, but this would work anywhere. So you learned how you can control this and how you can also return data when popping a screen. Data that can then be used in the place where the screen was pushed. Like we're doing it here, where we are using the result to update our locally stored selected filters. So we learned a lot of navigation related things in this course section, but you of course also saw that passing all this data and all these functions that then can be called from some nested widgets to update some data, that passing all these things around can be rather complex and annoying. And that's the kind of problem we're going to tackle in the next course section.